Hi class, this is Ms. Koltanova. I want to go over a particular topic from section 1.3 in Math Nation. I want to talk about how you would find the endpoint of a line segment if they already give you the midpoint. Let's take a look at this diagram. You'll notice that we have a line segment drawn here with a point in the middle. This point we know is our midpoint because we see that it has two tick marks, one on each side, showing us that it's two congruent segments on either side of that point. Now, this point we know is equidistant from our endpoints. We are going to call our endpoints x1, y1, and x2, y2. Our midpoint would be found using this formula. X1 plus x2 divided by 2 would solve for our midpoint x coordinate, and y1 plus y2 divided by 2 would solve for a midpoint y coordinate. Now, we're going to talk about what happens if we are missing one of our endpoints, let's say x2, y2. Now, we've learned that we can break up our equation into two separate little formulas in order to solve for xm and ym. So, for example, I can solve for the midpoint x value by adding the x1 and x2, my two endpoints, and dividing by 2. I'm averaging my x values to get my midpoint x value. I do the same thing with the y values. So I'm going to add the two endpoints, divide by 2, and that's going to give me my midpoint y value. Now, in these two equations, since we're dealing with them separately, we can have a variety of things being missing. We can have the midpoint x and the midpoint y be missing, or we could have one of the endpoints missing. So we're going to take a look at this situation when x2 and y2 are missing. Let's take a look at an example in your Math Nation books. We're going to work it out. I'm going to show you two different ways that we can solve this problem. We can do it this algebraic way, which I'm going to call method 1, or we're going to do a second way, which is not covered in your Math Nation books, and that's something called a visual method. So method 2, which is the one I really want to focus on, and I think is much easier than method 1, is a visual method. Now, the visual method is most appropriate when you're dealing with whole numbers or integers. But when you deal with decimals and fractions, sometimes it's easier to go with method 1. All right, let's take a look at the first problem. We're going to go to page 11. Actually, page 10. We're going to go to page 10. Page 10, number 5. Okay, here's our problem. It says M is the midpoint of line segment CD. C has coordinates -1, -1. Okay, great piece of information there. And M has coordinates of 3, 5. Find the coordinates of D. So this is our ask. This is what we have to give them as our final answer, the coordinates of point D. Let's draw this. I'm very into visuals, and you should be too. So let's draw line segment CD. I'm going to change my color here. Okay, so here is CD. Now you can draw this on a graph as well, the coordinates that you have, but I'm just going to do a sketch. So C, we know is -1, -1, and D, well, that's missing. So I don't have that other endpoint. I'm going to call that one x2, y2, because that's my other endpoint and it's missing. Now my midpoint, they told me is 3, 5. I'm going to call that M, because they called it M, and label it as 3, 5. Okay, now, what we usually do in order to get started is we label in our x1, y1, our xm, ym, and our x2, y2. Right here is our x1, y1. x2, y2, we already have that labeled in. It's our missing endpoint. And then our m, that's our xm, ym, the coordinates of the midpoint. Now, if we do it the algebraic way, method 1, we're going to think about the two equations that we use in order to solve for the midpoint values. So let's take a look at this. All right, now to get xm, I would use the equation x1 plus x2 divided by 2. Let's take a look at what we actually have and what's going to be a variable. Well, I have xm, that's my 3. I have x1, that's my -1. What I don't have is I don't have x2. That's going to be what I'm solving for. So let me plug in what I do have, and let's use some algebra to solve. So xm, that's my midpoint coordinate, that's going to be 3. x1 is -1 plus x2, well, that's missing. So I'm just going to call that x2, all over 2. So notice how we set this up just like a normal midpoint question. It's just we have a variable. What we're solving for, the variable, is now going to be part of the fraction. We can do some algebra to isolate that variable of x. So let's start off by dealing with that denominator of 2, because we hate having denominators. Let's multiply both sides by 2 so that we can cancel out the denominator. And now we're going to have 2 times 3, which is 6, equals -1 plus x2. A little bit more work. Let me scroll down. Okay, now 6 equals -1 plus x2. I'm going to isolate the variable, so I'm going to add 1 to both sides to get rid of that -1. And I have 7 equals x2. So I'm going to put that in. 7 is the first half of my answer. That's going to be the coordinate for the x value of my endpoint. Okay, so now let's do the same thing, but let's do it with our y values. So we set up our equation the normal way. To get our midpoint y value, we would add the 2y value of the endpoints and divide by 2. All right, let's substitute in. So we have the midpoint y value. That's your 5. We have y1. That's -1. We're going to add y2, but that one is missing. So we're going to keep it as y2, all over 2. And let's solve. So we're going to start off by getting rid of that 2 as a denominator. Multiply both sides by 2. These cancel. Now we have 2 times 5, which is 10, equals -1 plus y2. Isolate the y value. So we're going to add 1 to both sides. And now we get 11 equals y2, because these cancel. All right, so 11 is the y value of our endpoint D. So as our final answer, we're going to write down what our final answer is for the coordinate D. Our answer is D has the coordinate 7, 11. This is the algebraic method. It takes a lot of work. I'm going to show you now how we could do this with a visual method. Okay, so we've cleared it all off, and we're going to take a look at how we would do this using method 2, the visual method. This is how you do it. First step is you take your 2 endpoints that you are trying to set up with your equation with. So in other words, I'm going to take C, -1, -1, and then D is my other endpoint. That one is missing. So I'm just going to keep empty parentheses. And I put the midpoint right here in the middle, 3, 5. In other words, I stack it up vertically. This is how I start. I stack it up vertically. I start with the endpoint that I know right here at C. Then I put the midpoint right there in the middle, and then my missing endpoint at the bottom. Now, the concept of midpoint means that it should be equidistant to both of your endpoints C and D. Now, I'm going to use that concept to figure out how do I get coordinate D. Let me erase this. Okay, so think about it this way. To get from -1 to 3, I'm adding 4. So if I'm doing it to one side, then I should do it to the other side as well, because a midpoint should be equidistant. It should have the same amount on both sides of that midpoint. So then with this plus 4 here, I'm going to do 3 plus 4, which is 7. Now let's look at the other one. To get from -1 to 5, I'm going down 6. I'm going up 6, positive 6. Okay, so get from -1 to 5, I'm adding 6. So I'm going to do the same thing on the other side. I'm going to add 6. 5 plus 6 is 11. And look, I got the same answer I did with the algebraic method. Okay, so again, just to recap, I stack up my 3 coordinates with my missing endpoint on the bottom, and then I look, how do I move, or what do I add to get from my original value of x to my midpoint value? And then I'm going to repeat that on the other side. So we're going to also graph this to see if our work makes sense. Okay, so let's take a look at a graph. All right, so we have C at -1, -1. So right here. We have our midpoint at 3, 5, which is right here. And then we have our second endpoint that we just solved for at 7, 11. So it's going to go off the graph just a little bit, right here all the way at the top. Okay. And now we're going to connect all 3 points, hoping that they are collinear, which they are. And now looking at it, it looks like it seems correct. That midpoint does seem to be equidistant from points C and D. But here's a great check. Watch. We're going to use the concept of slope. You know, rise over run. We're going to start at C. We're going up 1, 2, 3, 4, 5, 6. So we're going up 6. To the right, 1, 2, 3, 4. Okay, to the right, 4. Okay, that should happen again if we're trying to get to D. So up 1, 2, 3, 4, 5, 6. And then to the right, 1, 2, 3, 4. And we're at D. Yep, it seemed to work out. Now, do you remember where these numbers of +6 and +4 came from? Let's take a look. They're right here. It was the change in Y and then the change in X. Okay, it's how much we had to add to our Y values and how much we had to add to our X values. Okay, so take a look at part 2 of this video, and we're going to do 2 more examples.